Welcome back to the Mob Mentality Show. My name is Austin Chadwick and co-host is Chris Lucian. And definitely excited for a fantastic conversation today with Uncle Bob Martin on could be a handful of different things, agile, TDD, architecture, design, functional, professionalism, software history. We'll see where we land today. But I'm excited about this. And I guess before we jump into some discussion, Uncle Bob, can you give us a little introduction for yourself?
Oh, gosh, yeah. My name is Bob Martin. I've been a programmer since, 50 some odd years now. Started out as an assembly language programmer in little machines and mainframe machines, and eventually C and C++ and Java and other languages like that. Now mostly I write things in Clojure. Been working on just about everything everywhere. So, embedded real-time systems and financial systems and simulation systems and all GUI systems and all kinds of gunk. So yeah, I guess I've been around the block a little.
Nice. Right on. Yeah, it's I was reading one of your books and it was talking about your experiences with the cards and looks like you're getting them out for those of you on the podcast. Yes.
Nice.
And yeah, I keep a few around just for get to smell them every once in a while.
Yeah, it was a good description for me because I had never seen it described in detail before. I just heard it referred to again and again, but I was just thinking like, oh wow, what a feedback loop, like we're so spoiled with feedback loops. And so
yes.
Yeah. So you put a bunch of topics on here to discuss today. Anything jumping at you that you want to jump into that you're excited about lately?
Well, you mentioned the cards, so that's kind of fun. We talk about ancient history. I'm in the middle right now of writing a book, which I'm calling iProgrammer, like the interface, except it's not the interface. And it's a book that starts in the 1850s and then starts walking forward all the way to 1975-ish. At least that's the first part of the book. I don't know about the rest of the book. The first part of the book is that, and we talk about Babbage. You got to talk about Babbage, and Ada. You got to talk about them. And then I start talking about people like John von Neumann. So I'm reading a book on John von Neumann right now, and I'll do a little bit of talk about Alan Turing, and then Grace Hopper, and John Kemeny, and John Bacchus, and it kind of all ends up with the Unix guys, Ritchie, Thompson, Kernighan, and to top it all off, there's a chapter on Simula. So Kirsten Nygaard and Ole Johan Dahl. And that's just kind of the way it's going. And the book is it's written for programmers, so there's a lot of technology in it. I talk about the languages, I talk about the machines. I'm talking to people who would understand that, so I'm not trying to gloss any of that over. So we learn about these machines and how they stored bits. And some of those old machines used to store bits in sound waves in mercury. That's how weird they were back then. Awesome. And I also talk about the people, because the goal of the book, or at least the first part of the book, is to introduce these people as humans as opposed to just as programmers. So you learn a little bit about their personalities and the trouble they got into and how they solved some of that trouble and how they didn't solve some of the personal trouble and a whole bunch of stuff like that. So it's been a lot of fun to write. I've made a whole bunch of very interesting contacts, and I'm having a ton of fun.
Oh, right on. Yeah, and what led you to go deep into the history like this? What's your kind of your motivation?
Well, I've been doing a little bit like that. I like to start my my classes with lectures, And I usually do science lectures of some kind or another. So I'll talk about, what the structure of water is and why water is important, or the distance to Alpha Centauri and things like that. I like to do science lessons, but sometimes I would venture into these lessons about the people. And the more I got into that, the more I realized how much I didn't know about that. This is the recent history of our industry. And I kept on, trying to come up with stories, and I didn't know where all these people came from or what they did. So about, I guess, 6 months ago, I thought, well, I'm just going to figure this stuff out. I'm going to learn who these people were. And as I read some of the stories, it's like, okay, I've got to publish this because nobody knows this stuff. It's it's all written in history books that normal programmers wouldn't read. So I'm reading those history books, and then I'm trying to present it to the technical folks in a way that they're going to want to read. So that's how I got into it.
Yeah, that sounds really interesting. And so in your process, I can see that you're reading very specific books about the individuals. And you said kind of contacts that you've been branching out to. So is that kind of how you've been approaching this, is just like diving deep on one person and summarizing or something along those lines? Or is there more to it than that? Finding people that knew them, or new people that knew them?
So it's definitely diving deep on individuals, or at least that's where I thought it was going to be. Turns out, though, that 50 years ago, the number of programmers in the world was so small that they all knew each other. So there was a lot of cross-fertilization between all of them. You can't tell the story of Grace Hopper without talking about John Bacchus. You can't tell the story of John Bacchus without talking about Edsger Dijkstra. So all these people interacted and knew each other, and they fed off of each other. So that kind of twists through the entire set of chapters. The chapters are still organized around people, but you see these characters coming in and out and weaving their way through the whole story. I have made contacts with some of the people who worked with my subjects. Virtually all of my subjects are dead at this point. Not exactly all of them. There's a couple who are still alive, although they're generally very silent at this point. But most of them have passed. And so I have been able to talk with some relatives and some coworkers, and just to gain some insights that you couldn't get any other way.
Wow, that's fascinating. Oh, wow. And so how far back did you say you were going for this history?
Well, I'm going back to the 1850s because I wanted to get Babbage. But then there's this great big gap until the 1920s, 1930s, where we start to get into Turing, and then von Neumann, and then you got World War II. And World War II is really the event that created the modern computer. Now, it probably would have gotten created anyway, but it was particularly created because the computational needs of that war were so great that you needed machines to do it. Prior to that, they just filled rooms full of people with adding machines. And they took very clever mathematicians and they parsed out the problems, and they got people with adding machines to just do all this immense amount of addition, just tremendous amounts of addition, subtraction, multiplication. These people didn't know what they were doing. They were just adding numbers, right? And then the mathematicians would gather up all those numbers. And of course, what they were really doing was solving simultaneous differential equations, right? But in the end, there was just too much of that to do. And there was some automation that would help. IBM was giving them card machines, these cards, and they would punch data into these cards and run them through adding machines and multiplying machines. But it was still all very manual. And eventually it wound up with gigantic machines that were using gears and counters and relays and motors that filled entire rooms. And they were driven by paper tape right at the end of World War II. And the people who saw that were people like Grace Hopper. Grace Hopper actually used machines like that. John von Neumann did some very early nuclear implosion calculations on machines like that. And everybody's looking around going, well, this is great, but these machines are like one-offs, and we're going to need a lot more of that. And von Neumann comes along and says, yeah, and this whole paper tape idea is dumb. We're going to have to figure out to have some way to store the program in the computer. It's all very interesting stuff, right? So
yeah. Wow.
It kind of reminds me a little bit of because there's like the big machine learning boom right now, I guess. And it's funny because when I talk to people and they're like, oh yeah, we got this deep model and blah blah blah, and I'm like, go back to think about where this model is right now, and you know so little about what's going on inside. And if you go back to what people were doing by hand, like ARIMA models and working through the stock market and everything like that, and so like this jump in calculation capacity and the amount of stuff going on inside, and the sheer amount of calculation and computation that has even jumped since then, it kind of reminds me a little bit of that as well. And I find it interesting to take a step back and point back to the way things were, and are we actually performing better given the resources that we have?
Tell you what, we're doing a lot more additions.
Yeah, exactly.
I mean, Angry Birds needs a lot of additions.
Yeah, exactly. Exactly.
Yes. Critical stuff. Yeah. So it was interesting you were talking about this. It reminded me, I was recently reading one of Deming's books, and he was talking about how he was giving statistical advice for census and market research in that day, and how much manual labor it was at that time. And I was just like, whoa. And so comparing that span of time to my little, 15 years of software programming, one thing I've realized, and I wonder if it holds true at all to the longer span that you've been researching, is that from last 15 years, especially the last 5 years, the more mob programming I've been doing, I've been able to see a lot of different technologies and a lot of different programming languages in full stack. And one thing that I've kind of walked away with is code is code. You know what I mean? Like, there's dramatic differences, of course, but a lot of the principles hold true. How true is something like that going from not like early 2000s to 2023, but 1850 to 2023? Is code, or is it like dramatically different and at some point?
It's quite remarkable how the problems that faced Grace Hopper using a machine that executed instructions on paper tape and could not do branches and could not do loops. So it was just a sequence of instructions. For a long time, people had no idea that you might want to repeat them. So in the end, what she would do is she would take these strips of paper tape, and they were big. They were like 3 inches wide. And they had 22 columns, not the little paper tapes that you use in a teletype. These were really long bits of paper tape. What she would do is she would glue the ends together and turn it into a loop.
Yeah.
And then they did have little escape instructions. So if a certain condition overflowed, it would stop the machine. So they could run the loop and make sure that it overflowed at the right point. The machine would stop, and then they'd have to pull that loop out and put the next set of instructions in. And that's also how they did branches. If they had to do a branch, they would stop the machine, and then you could either move the tape to the next execution point in the branch or bring in another tape or something like that. And in all of that, they started to realize that you needed repeated stretches of code, not in loops, but just repeated stretches of code that you had written elsewhere. But it's going to work in this program too. So wouldn't it be nice if you could cut them and kind of paste them into your tape? And they created libraries of those little stretches of code, which they called subroutines. But that was just a bunch of tapes hung up in a cabinet somewhere, right? And then bit by bit, they started, getting better at these subroutine ideas. And then von Neumann comes along and says, you got to put the doggone software in the computer. You can't have it on a paper tape. And bit by bit, they moved the subroutines into memory. And then it took a very long time for them to realize that you really did want to be able to return from a subroutine. They didn't have any of that stuff in the hardware. The machines didn't have stacks. They didn't calculate return addresses. They didn't do any kind of subroutine stuff that we would normally think of as usual. They didn't do any of that stuff. So very, very interesting how the needs of the programmers strongly affected the hardware engineers as they would create newer and newer computers with more instructions that the programmers said, we can't code without these kinds of instructions, guys. Very interesting stuff. And eventually you get to modern computers, with stacks and lots of memory and ability to do functions and recursion. Recursion, what a huge controversy that was. There was an immense controversy over whether languages should be recursive. And Dijkstra was going, yes, they must be recursive. And everybody else is like, nah, we don't use recursion nonsense. It's really interesting stuff.
Well, that's kind of funny. I feel like I was listening to the end of Clean Architecture fairly recently, and I think you were kind of talking about languages broadening over time, and then newer languages limiting over time. And I really love that concept. So it's cool because I think the ending of that book is almost in Clean Architecture. You're constricting over time, and this might be a really cool way to visualize the growth of the available options to the developer over time before that. So kind of an interesting perspective. I like it.
Nice.
Languages are, we're in this trap right now because everybody's hunting for the perfect language, and there is no perfect language. So we continue the hunt and continue the hunt, and there's the next new language and the next new language and the next new language, and none of them are new in any sense. Right? We've kind of explored the language space, and we keep on trying to invent something new, but there's nothing new in these languages that are being invented. And we're spinning, just sitting there spinning. And you have to learn them because you might have to use them, but there's no point in learning them because they're not new. So that is a symptom of an industry that has reached a plateau and doesn't realize it's on the plateau. And it's going to have to settle itself out. At some point, we're all going to have to look, with cold, icy stares at the languages we use and go, well, damn it, I guess they're all the same. We ought to just pick one or two of them.
It's the top of the S curve is now nice and flat, right?
I think it is. Yeah. Now, every once in a while, somebody comes up with some new idea, but I haven't seen a real new idea in languages in a very long time.
Yeah. It just appears that they're baking into the languages more and more syntactical sugar. Seems to be what I've noticed is like the new release of the language. But I wanted to return to the history a little bit more, and it reminds me of a funny thing when I've never considered it when you were talking about loops and branches and cutting and pasting being literal things that they actually did to physical.
Yep.
And it reminds me of this story where someone saw a floppy disk, and it was a younger person, and they said, whoa, what is that? It looks like someone 3D printed a save button. They're like, and I just had that experience right now, that's what a loop was.
That might be an urban legend, but it's a good one.
Yeah.
Another one like that's actually true is Grace Hopper pulling a moth out of the relays in an early computer and finding a bug in the system.
Oh, nice.
Literal bug. Yeah.
Real bug. Yes. So my follow-up question was, I found it fascinating. You were also looking at kind of the people side of things and not just the tech and the technology. So this being the Mob Mentality Show, I'm wondering if you've seen any collaboration, teaming, kind of people sort of patterns or observations from looking out over, the 150, 180 years there.
The first pair of programmers were probably Babbage and Ada Lovelace. People talk about Ada being the first programmer, but that's not really correct. She certainly collaborated with Babbage on the programs that might have run in the analytical engine. But it was a very deep collaboration. They sat together for long periods of time. They scribbled notes and erased and wrote new notes, and they corresponded back and forth it very intensely,
Mm.
and on this topic. So in some sense, you could look at the two of them as the first mob, except it was a pair, right?
There's
The
a
first
pair,
set of pairs. The next one that's significant is Dijkstra and, oh, I can't think of his name. It begins with a Z. But Dijkstra and this guy Z, I'll think of it in a minute, wrote the first Algol compiler. And they weren't actually in a race because Norwegians don't race. They're not allowed to compete. But they were in a race anyway, and they were the first ones to get one done. And they paired on it the way that you might think of it as pair programming, but they did it in a really interesting way. They would write equivalent chunks of the software. Dijkstra would write one, and this Z fellow would write another one, and then they would run them in parallel and compare the outputs. And then that way they would learn a lot from each other. And the supposition is that the reason they beat everybody else was that their debug time was so low, because they were fighting or beating against each other. They were doing this dual programming instead of pair programming. So that's a very interesting technique that, for the most part, has fallen by the wayside. We don't do much of that anymore. Now, when you're pairing, you're kind of doing that, but you're not doing that by executing in parallel, right?
Yeah.
You've kind of got multiple brains working at the same time. But when it comes down to actually getting these things to sit and execute in parallel and then compare them, you could learn an awful lot that way.
Like a battle of the banjos or something.
Yeah, sort of like that.
Yeah. Well, it was funny. We've actually done something similar like that on occasion. So I remember back, it's about 5 years ago, we're in a mob of 3, and we're like, we had 2 competing ways to get something done. And we're like, well, one of the ways involves a particular technology stack, and that expert was in another mob. So we're like, hey, can you come join our mob for a few weeks? And then we split into 2 pairs, and we both tried out, competing ways, and then we compare notes every couple hours. And then after about, I think it was a few days or week of that, we said, okay, one of these is working better than the other, and we rolled with that. So it does occur sometimes, but I agree with you. It's less talked about for sure. Yeah.
Stressful technology choices, I think.
Yeah.
Yeah. It's like, oh, I don't know if I want that or that, or and in the end, it's probably would have been fine just rolling the dice anyway.
We have done that too. Yes.
Yeah.
Nice. Cool. Yeah. So you mentioned the quest for the perfect programming language. And then I noticed earlier in the show you mentioned that you're spending most of your time in a functional language. Which one was it again? Clojure. Nice.
Yeah,
and
Clojure.
Is that the one you wrote? I saw the video series that was like the space.
Yes.
Yes. Was that written in Clojure? Okay.
Space War. Yes, that was written in Clojure. Yeah.
Okay, so I've never written Clojure, but I watched that series. So
okay.
So what's led you to more experimentation with Clojure and functional?
Well, for a very long time, I was an assembly language programmer and then a C programmer, and that was my world. And people would talk about languages like Lisp, and I would kind of wrinkle my nose and go, oh, heavens, why would we need a language like that? And I didn't know Lisp, so I didn't care. And then somebody said to me, and this is a long time ago, maybe 15, 20 years ago, somebody said, Bob, you should get this book. Now, they just gave me the title of it. And I thought, oh, an interesting book. Okay, well, I'll go get that. Structure and Interpretation of Computer Programs. And I bought it. And it was one of those books that was out of print. So I managed to get it either on eBay or maybe it was from Amazon, but the used part of Amazon. I can't remember. And then I stuck it on a pile and I didn't read it for 3 years. And then I started reading it just one day on a whim. And the book completely captured me. This doesn't happen very often, especially with technical books. But this book just grabbed me and shook me. Yeah, and I'm reading it and going, my God, this is really interesting stuff. And read. I get to like page, I think it was 250. And by this time, we've gone through all kinds of different programs in Lisp, Scheme. It was the language Scheme, but that's Lisp. So we've gone through program after program after program after program, and they stop. And it's a very interesting moment in the book because they slam on the brakes and they say, okay, now we're going to ruin your world. They don't say it that way, but that's kind of the intent, right? We're going to introduce a concept that is going to break our model of computation. It really is horrible. It ruins a lot of stuff. And the idea was that they were going to introduce the first assignment statement. And I was just floored by this. I had to stop and go back through all the programs we had read before to prove that there were no assignment statements in any of them. And after I had proven that to myself, I thought, holy cow, this is really interesting. So then I'm reading and reading and reading more, and they're introducing assignment, and they're showing how it corrupts things, and sometimes it's necessary, but oh boy, it causes trouble because statements here and statements here with an assignment between aren't living in the same system. There are temporal differences, blah, 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 blah. And then 50 pages later, they stop again, slam on the brakes again, and say, okay, now we're going to introduce the next thing that's going to ruin your software. And they introduce threads. And I thought it was fascinating to me that they equated the difficulty of threads and assignment as though they were equivalent roadblocks, equivalent problems in the construction of software. So after I read that book, I thought, well, okay, I have to learn Lisp. And I just happened to run across Rich Hickey's Clojure, which is Lisp that runs on top of the Java, runs on the JVM. And I thought, that's a good language. I'll just learn that. And that was probably 13, 14 years ago. And that's the language I've been using ever since.
Oh, that's such a dramatic shift from one book of a huge influence. It sounds very impactful.
It was a very impactful book. It's written by the two computer science professors at MIT, Abelson and Sussman. And the book is now free. You can just download the book. The PDF is there. And there's all these wonderful lectures that were videotaped 30 years ago.
Yeah.
And they're drawing parentheses on a blackboard.
Yeah.
Pretty cool.
I think I've only written a few Lisp programs in the past, but I did. There was sort of an elegance to it once you got past the readability piece, and so like I run into a lot of maybe like really big functional fans. And talk about many of the things, assignments and or threading, although I hear of functional in general as being a way to solve threading problems, not necessarily introducing threading as being a problem, right? But yeah, I know it goes here and there. But I guess do you I find like a general resistance to a jump to functional when talking, I guess primarily talking to OO programmers, but when showing the benefits or something along those lines. Yeah. Do you run into that at all, or maybe a fear or resistance to that?
I run into a fair bit of stuff like that, where you'll have one faction who is the functional faction, and they're saying, "Oh, I'm so glad I'm not doing objects anymore. Now it's all functions, 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 functions." And then these people will say truly silly things like, well, we don't need design patterns anymore because we have functions.
I've heard that.
We don't need design principles anymore because we have functions, as if we didn't have functions, starting in the 1960s. So that bothers me. And then you have the opposite ones, who are the people who have not done functional programming yet, and they're saying, well, that's just too academic and too slow, and I don't want to deal. Besides, there's too many parentheses. I don't want to see. So there's all of this. What's a good word for this? Prejudice is a good word. It has been prejudged. Yeah. So there's a prejudgment or a prejudice involved. And what I've discovered, because I was victim of these prejudices myself, right? So what I have discovered is that when I write software now, it is a mixture of all of these things. The systems I write are imperative, they're object oriented, they are functional. I don't try to segment them and partition them anymore.
Yeah.
All of those techniques work fluidly together. They are orthogonal and they are complementary. And you can build systems very nicely out of imperative functions that are don't have assignment. They're non-mutable. They don't assign things. Other things might, but they don't. And then they are structured using object techniques so that you can manage dependencies between modules. Works beautifully. So I actually wrote a book about that.
Yeah. Well, yeah, I hear maybe the extreme viewpoint is going to harm the end product in the end. If you approach everything with moderation, you'll be able to have the right tools in your tool belt available at the right time, something like that.
Yeah, I'm not sure moderation is the right word, but lack of prejudice might be a better way to think of it, right? These are all tools, and they're good tools, and the tools have a place to be used. So use them, learn them, and use them.
Nice. Yeah, and I think the right tool for the job kind of thing is been my limited experience so far, and it seems like a lot of modern languages kind of allow you to do both, right? And so I'll be in with the mob, and then someone will join the mob, and then they'll suggest a functional way to solve it versus a more different way to solve it. And then the language will allow us to kind of try that without like switching the whole tech stack to Clojure or something like that, right? And so that's kind of been my experience. And I guess I've never jumped into a full functional language before. And I guess for anyone else who's like me, what would be your advice? Is there value to jumping full into the deep end of pure functional land and then coming back out? Or do you just keep dabbling with it in languages that allow you to do that as you need to?
My advice to everybody on just about everything is learn things in the safest place you can. So if you're going to learn test-driven development, don't start doing it at work, because you're going to screw it up. And when you screw it up, you're going to abandon it. So do it at home. And everybody has projects at home because we're all programmers. So we all work at work, and then we come home, and then we work more. And so do those things at home where it's safe. Or if not at home, then maybe at lunchtime with a group of people, or maybe on a Saturday at a hackathon or something like that. Learn those things where it's safe. And then once you've mastered them well enough, you can bring them to work in a safe way. And I would say the same thing about functional programming. Get a functional language, get F# if you want to, or get Clojure, or get Haskell, or there's a whole bunch of them out there, right? Get a functional language, take it home, and learn it. And then once you have done that, well, then all of a sudden, if you go back into Java or C# or something like that, they've all added these functional, features, which are, I'll put quotes around the functional, but they've added all that stuff. And all of a sudden you will see how to use it well, and why they're there, and why they are functional and why they aren't functional. But you'll have a much better insight into why those features are there and how to make good use of them.
Nice. Right on. That sounds good. And I guess so. This might be a weird question, but you have TDD as one of your topics for today as a potential topic.
Sure.
And I'll have to say that XP and TDD and clean code were huge game changers for me. Like, my development experience went from a lot of more stress to a lot more calm and a lot more much higher certainty of what was going on, and much higher continuous delivery and things like that. And one side effect I've seen as well is I feel like if something is test driven, I'm not super worried about it, and I'm almost ambivalent whether it's functional or not, or whether it's this or that, whether the language is crazy type safe or more loose, you know what I mean? And so it's almost like TDD has made me, I almost feel like it's made me overconfident. But I haven't been bitten by it yet. And is it just going to happen? You know what I mean? Eventually, like not backing off on the design, but like kind of these squabbles of, super type safe versus not, versus very functional versus not. Does TDD kind of barricade you from some of the consequences or all of them? What are your thoughts there?
If you are following the discipline of test-driven development,
yeah,
and all of the fears of bad design and type safety and functional versus non-functional, all the scare tactics and all the fears reduce in their intensity by probably an order of magnitude, because you've got those tests.
Yeah.
And the tests are a massive security blanket. So one of the reasons that I gave up type safe languages, because Clojure is not a statically typed language. So one of the reasons I gave up on statically typed languages is that I had written tests in Java for a decade and never needed the type safety. And the type safety, in fact, was getting in the way. The static type checking was becoming an impediment. And I didn't need it because I had tests. So if you had asked me that, 20 years ago, I was one of the C++ guys going, no, we've got to have static type safety. You don't understand what it was like when we were programming in C, and C was untyped. It was hell. It was hell, I tell you. And then, you start learning about test-driven development and how that just makes all those fears subside. And now I look around and think, well, why do I need the compiler to check my types and get in the way and force me to declare all these things when I'm writing the tests that are doing that work for me? And the tests I'm writing are doing it better than the compiler could. Now, I write a lot in Clojure, and Clojure has this very interesting framework called spec. And it allows me to specify the types of things in extreme detail. But the types are checked at runtime under my control. I can say when I'm going to check the types, and I can say which types I'm going to check. So I can control all of that myself, and I do that as part of my tests. My tests will invoke these spec checks. Right? And the main body of the code usually does not, although often in the main idle loop, I will put a massive type check while I'm under development, because every once in a while you find some goofy thing. And I find that to be extremely useful. The spec checker would check anything that a static typing compiler would check, but it'll also check dynamic things. So, for example, you might have a data structure, like let's say it's a balance sheet. And in the balance sheet, you sum up all the sums and you get a 0. You could check that as part of the type of the balance sheet, which you cannot do in a static language. Right? So I find that really, really useful. So I still do type checking. I just do it dynamically. And I do it under control of my tests.
Yeah. One of the people I mobbed with, he wrote, I'll have to put it in the show notes when I look it up, wrote a dynamic type checker for JavaScript. So it's very, very similar. Chris, if you remember the name, shout it out. But that was a fascinating experience as well. And it's very similar to what you're talking about with the spec thing. And what I've noticed with types is, and I wonder if this is true for you too, if there's a lot of typing going on, it doesn't eliminate my need for tests, but it might reduce the amount of tests I need, right? And so if Signet, Signet is the name. Thank you, Chris. So for example, a test before that would need to test, edge cases and crazy things happening, I would have to have more tests without the types versus not. But then you're right, the more the types get in the way, like I remember you saying in one of your videos, certain design patterns aren't possible unless the language allows some dynamic non-static typing, right? And so it's always like engineering a trade-off. Yeah, so has that been your experience too with type? Does that reduce the amount of tests for you, or have you found another way around that?
Well, when I'm writing tests, when I'm doing test-driven development, I'm writing tests. What I am checking is the dynamic behavior of the system. And the dynamic behavior of the system cannot function properly if the types aren't right. So indirectly, those tests are checking types. Now, in complex data structures, I will use Clojure spec, and I will nail down the types. I will nail down the structure of these complex data structures, and then check that in my tests as well, which I did not do in Java. In Java, I could trust that the data structures were consistent because of the static type checker. So yes, in that sense, I write more tests now that check dynamic types than I did when I was writing in Java.
Nice. Very cool.
Yeah, it's a good question. I think there's this kind of in the JavaScript land, there's the TypeScript versus runtime type checking, and a huge migration to static type checking. But you do get this you can kind of get whatever object in there, and especially if you're getting it from an unknown source, and you would never know at runtime if you actually fulfilled the constraints of the object, unless explicitly checking for those things. So it's a pretty interesting.
And I just realized I had a secret covert reason for asking this question, Uncle Bob, because me and Chris have been debating this. Like, do we need to convert stuff from non-type checked languages to typed ones? And so it's been so. I unintentionally brought you into a little debate here.
Well, the debate is an extremely old one.
Yes.
It goes way back.
Yeah.
And the mood of the industry oscillates about once every 10 years. So we will go through a period of time where everybody is statically typed, and then everybody gets sick of that. So they think, well, we could do dynamic typing, and then everybody's dynamic typing, and then everybody gets sick of that because they have too many runtime errors. So we could check our types, and it just goes back and forth.
I feel like that's what's happening with WebAssembly. like right now, everybody's like, yeah, WebAssembly, we can write it. We can write our JavaScript in C#. And but that certainly feels like that's probably part of that.
That's one of the pendulums in our industry. Another one of the pendulums in our industry is, should we be executing out at the workstation, or should we be executing in the cloud, or in the mainframe, or at the terminal? Where should the intelligence be? And we can never decide. Right? Every time we do it in one place, we realize the other place would be better. And then we do it over there. Oh, but it would be better over there. Can't decide these things. They just oscillate back and forth every 10 years.
Awesome. So I think we had a note here to talk a little bit about maybe professionalism or agile or anything along those lines. Is there, I think, your comments in kind of the clean code series about professionalism always kind of struck me as important ones. And it's funny because you just run into a lot of different interpretations of what professionalism is, right? And so I think there's like this dichotomy of what does professionalism mean in the software space, and who defines that, right? Like, because do the software developers define what professionalism means to software development, or is it somebody, that sort of
thing?
So
over the decades, the people who are professionals defined their profession, and they did so by enumerating disciplines, standards, and ethics. those three things. Standards are just things you just don't go below. Right? There's a line, and you say, okay, I can do the stuff above the line, but I'm not doing the stuff below the line. And ethics are, your intent towards your customers. How are you going to benefit your customers? And disciplines are the things that are the rituals that we apply to stay above the standards and to address our ethics. And those things apply in every profession except ours. Now, that's just because our profession is ridiculously young, right? I mean, people were not, when I was born in 1952, there were perhaps 1,000 programmers in the world, maybe, right? And 10 years before that, there were none, right? In 1942, nobody was writing code for any machine because there weren't any computers at all. Maybe you could say Alan Turing in his Turing machine in 1936, and you could go back to Babbage and say, well, at least he thought about it. But this is a very, very new profession. It's also unique, I think, in the history of mankind that such a young industry, so I don't want to call it a profession yet, such a young industry has had such a massive effect on society. Our society could not exist without computers. And that is a very recent event. That's just the last few decades. Yeah. But we have built a superstructure on top of computers and upon the software that's in those computers that there's no way out of, right? We could not go back to the 1950s. Our society simply could not work. And so what we've got is a society that depends existentially upon a group of people who have not yet defined their profession, that don't know what it means to be professional, don't know what it means to be ethical, don't know what disciplines they should follow, don't know where the standards are. And I find that to be, in some sense, terrifying.
Yeah. Absolutely.
Sounds now, like the other side of that is that the industry is growing at a rate that is insane. I mean, we've been on this exponential growth curve ever since the industry started. And at some point, everybody on the planet is going to be a programmer because we're running out. There aren't enough people anymore to do this job. Every once in a while, we have a little tiny recession. We're kind of in one right now. Yeah, little tiny recession, but that'll last maybe 6 months or a year. And then all of a sudden, the demand will pick up again because there is no limit to the amount of computation that we apparently want to do.
Yeah.
I mean, my thermostat has more power than an Apollo capsule, right? So it's just kind of crazy.
That is mind-blowing. Yeah.
We are going to have to do something about this. Yeah. And if we programmers don't do something about this, then government will, and government will muck it up horribly. So it would be far better if we, like the doctors did, like the architects did, like the lawyers did, we sit down, and I don't know who does this, but somebody does it, and decides what the ethics and standards and disciplines are, and comes up with a means for defining and enforcing that profession. I think it probably happens in little tiny groups, guilds, where people join a guild and they have their own definition of professionalism. Somebody else joins another guild, they have their own definition, and then it all kinds of works out in the marketplace of ideas.
All right. Well,
I just hope that we get there soon enough, because otherwise government will march in there and tell us all.
Yes, and that's the big
how we have to use our braces.
Sure. Yeah.
Well, before you close, Chris, I guess I'll just say, next time I need to tell a scary story to a bunch of kids, I know what to tell now.
You all have to become programmers.
Yeah, and the world is going to depend upon your skills, even though we don't know what we're doing. All right, yeah.
All right. Well, it was a pleasure speaking with you, and so to our audience, if you know somebody who's really maybe interested in, yes.
You want to let them plug something?
Oh yeah, absolutely. Is there anything that you want to plug or share before we close out the show?
Oh gosh, well, you guys said that you've watched a whole bunch of the videos that I've got online, right?
Yeah, yep.
That's at cleancoders.com, the plural, cleancoders.com. And I do a regular set of courses that are online now. Everybody does their courses online. So I do that as well. And you can find those at cleancoder.com. And you can follow me on X. It used to be Twitter, now it's X.
Yeah.
Follow me on X at Uncle Bob Martin.
Okay.
That's probably good enough.
All right, great. Yeah. And thanks for reminding me. I missed my checklist. I'm back on my checklist again. Yeah. So to our audience, if you know somebody who's interested in the history and maybe the technical history of software development, so there's probably some people really deeply interested in that. Maybe recommend this episode to them, or if they need, if they think that professionalism exists in software, maybe we can show them this episode. And be sure to like and subscribe and ring the notification bell. And thanks for listening, and we look forward to next time. And again, Uncle Bob, thanks for joining us on the show. And to our audience, have a great day.
See ya.